Okay, students, today in this session we are going to solve some questions, important questions of ethers. Okay, so these are going to be very helpful not only for boards. Okay, these are for board. It is definitely useful for the boards because these are all either previous board exam questions or depending on the previous board exam, these questions are selected. Okay, so the presentation you should be able to know in the board exam. The main problem will be, even though you know answer, you may not be able to present it in the right way. That presentation also we will come to know, and for competition purpose also they will be molded into the objective types. Okay, so that time how to save your time and don't how you should not confuse with the options, that also we will discuss. Okay, so like this question is a one question for the board exam but three MCQs. Okay, so here I will tell you the question. Here there are two reactants. One reactant is HI. One reactant is what? HI. So another reactant is this one. So what will be the major product formed? Okay, major set of product formed you have to identify. Already in our one shot lecture of the ethers, I told you two topics are very important in the ethers. Williamson synthesis. You can check any board exam or any entrance examination. Mostly questions will be from these two topics only. Reaction with HI and reaction with the after the reaction with HI, then Williamson synthesis. Okay. So let's see. You can answer, and I will tell you the how to present the correct answer. Okay. Okay, here the first answer I am telling you. There is a simple trick. Okay, trick I will write it here. In case of the unsymmetrical ether, this is unsymmetrical ether. So this is the oxygen which is attached, and here it is ethyl group, small group. This is what group? Small group, and this is large group. Okay, so you have to first of all, in case of the unsymmetrical ether, so you have to differentiate them with the two parts, which is larger group, which is smaller group. Okay, and when you are heating the HI, the iodine will go to the smaller group and hydrogen will go to the larger group along with the oxygen. Okay, so answer will be like this, but you should present it in a nice language. Their first answer will be CH3, CH2, CH, CH3 and CH2, then it will be OH. Okay, then it will be OH. Understood? Then second option will be CH3, CH2I. Okay, so this is the second answer. So like that you can try for the B answer also. Okay, so first major product obtained are 2-methyl butane 1-ol and iodoethane. Now let's see about the second part. Okay, same procedure will be almost same. Only thing you have to do it in the other way. There is an exception also. I told you, if you remember, if you go through the topic again and again, organic, you have to go through the topics again and again, practice more and more questions. Then only your options, your answer will be correct. Okay. So again, I am repeating that exception in case of the tertiary. So this is a tertiary carbon atom. Okay. In case of the tertiary, iodine will be attached to the tertiary carbon. Therefore, obviously, hydrogen will come and attach here. Okay. So second answer I am writing is the answer here. CH3, CH2, CH2OH. This will be the first product. And here iodine will be attached I CH3. Okay, then it will be CH2, CH3, then CH3. This is the second answer. Okay, so names I think all of you can write it or not. Propane 1-ol. What is it is? Propane 1-ol, and here the naming will be done like this. This is the major chain. Okay, So 2 iodo 2 methyl butane, 2 iodo 2 methyl 2 methyl butane. This is the second answer. Okay. Now third answer also another exception. When benzene ring is there, what product is must? See, I am writing here H and I. Okay. Where iodine will go, where hydrogen will go. That is what you have to decide. Always remember phenol is must. So hydrogen will go on the oxygen, iodine will go to the CH2. Then product will be something like this. Product will be phenol plus on the benzene ring it will be CH2 with iodine. Okay. So this is phenol and this is iodobenzene or benzyl iodide. Okay, this is benzyl iodide. Okay, and this phenol I think everybody know. Okay, make a clear notes. These questions are to be directly there. You may get same to same question. Okay, now let's see the next question. Okay, here are next are some complete the following questions. We will be covering all models like conversion questions are very famous. Okay, and complete the following reactions are very famous. Some reasoning questions, major minor product. We will try to complete maximum to maximum questions so that you should get the same to same question. I will try so that same to same question will be reflected in your board exams. Okay. So let's see the first answer. What is the first answer? Major products. Okay. First of all, it is cold and it is HCl. Okay. So this will be salt. Salt formation will be there. This will be H positive and Cl minus. This will create a salt. Okay. So here this oxygen I am writing here oxygen. Okay. So to that oxygen, see here two ethyl groups are available. How many ethyl groups are available? Two ethyl groups are available. C2H5 whole twice oxygen and this H plus will be attached over here. So this H but plus side you will write outside. Okay. And this Cl minus will be outside. So this is a complex. There will be a coordinate covalent bond between the oxygen and hydrogen. Okay. So this is the first answer. Then see here, this excess makes a lot of difference. Excess makes a lot of difference. So because of the extra H and I, okay. So I will tell you how to cut the products. How to cut the product like Bahubali, I tell you. So H and iodine. Excess is there, so one more HI will be there. Okay. So you have to cut like this, you have to cut like this. Okay. This is, don't tell it to anybody and don't write the same thing in the exam. This is only memory technique. Okay. So here first product will be C2H5 iodine. Second product will be H2O. Third product will be C2H5 iodine. Okay. So ultimately we are getting 2 moles of C2H5 iodine. Okay. And 1 mole of water. That is the second product. Okay. Then you are heating the chlorine. In sunlight, there are two types of light in the board exam. Sunlight and diffused light. In the diffused light or dark, there will be only one chlorine will be participated at one time. If chlorine is there on the arrow, if you find sunlight, that means all hydrogens must be replaced by the chlorine. So total how many chlorines will be required? 5 chlorine here, 5 chlorine here and 10 chlorine for outside hydrogens. So total we require 10 moles of chlorine. How many moles of chlorine? 10 moles of chlorine. So first product will be C2H is there. So now that H will be replaced by the chlorine. H will be replaced by what? Chlorine. C2H, C2Cl5 and oxygen again C2Cl5 and this hydrogen will come out, will react with remaining. So 10 hydrogens are there, therefore there will be 10 HCl. There will be how many HCl? 10 HCl. Now this is again Williamson synthesis. Just like what? Williamson synthesis. Okay. So in this reaction, what happens? Williamson synthesis uses NaI. Okay. Minus will be there. So minus NaI, you can write it here, or as an additional product, you can write it here also. Okay. So, but write only at one place. Then the product will be CH2 double bond CH single bond CH2, okay, against oxygen, then CH2, okay. So I am continuing here, CH2 CH double bond CH2, okay. So minus Na is already written here. Now it is called as a di. Commercial names I specially mentioned. So if you have not gone through any of the commercial name, it will be a problem. Maintain proper notes in organic. Go through every lecture. Don't miss a single word. Okay. So diallyl ether. So 4 questions we have solved. Okay. As I told you, I will be covering all models. Now we will be doing some conversion questions. We have done major minor product question. We have done complete the following. Now we are going to do some conversions. Okay. So every format you should be aware of that. Not only knowledge, it should be able to in the presentation manner. Okay. So first of all, see the requirement. Methyl iodide, CH3I. We have CH3I. And what we wanted to convert it to? Methyl ethyl ether. What you want to convert to? Methyl ethyl ether. So this is what we require. This is given and this we want. Now it is up to you what you will use, but they want that this product is to be made. Okay. So first of all, what I will do, I will use the aqueous KOH. What I will do? Aqueous KOH. Then obviously potassium and iodine will be removed. Be careful, it should be aqueous. If it is alcoholic, sometime it may result in elimination. Okay, so this will be CH3 and in place of iodine, what it will be there? OH. Okay, now if I put sodium, okay, then sodium being more metallic than the hydrogen, hydrogen will come out as a minus half H2, minus half H2, then it will be CH3ONA. Now see here, up to here we have achieved. Always your one eye should be on the product, what we want, and another eye should be what we should have. Understood? So then to prepare this, what we have to have? Only C2H5 iodine. Okay. Then if I treat it with the C2H5 iodine, C2H5 iodine, then this sodium from here, iodine from here will be eliminated. Then I will get our required product, desired products. Okay. Is it clear to all of you how to complete the following conversions? You may see in the books or notes, but how to approach that you will be clear only when you go through the video lectures. Okay. The chemistry problem is that you will feel that you understood from the books, but when you do other questions of the same format, you will not be able to solve. Okay, that is because approach will be clearly explained in the lectures. Answer will be clearly given in the books. So reading the books, only that question you will be able to solve. Going through the some video lectures, you will be able to solve all related questions. Okay. So this is about the first question. Make a note. I think you will be able to solve the second part now. Okay, second part I am explaining ethylene. Ethylene means CH2 double bond CH2. And with this we want to prepare divinyl. Divinyl. Vinyl means clearly I told you in the IUPAC nomenclature. So if you are not aware, at least by this time, you should be aware of it. Okay. So CH2, here it will be CH2. CH2 double bond CH, oxygen CH, double bond CH2. This is what they wanted to prepare. That means in place of the one hydrogen, we want that CH2 must be introduced. Okay. So clearly I am telling you, listen carefully. So here 2 moles of hypochlorous acid. Hypochlorous acid is HOCl. Okay. So let us take Cl will be here, OH will be here. Let us take Cl will be here, OH will be here. Then chlorine CH2 double bond will become as a single bond. Then CH2 will be OH. Here it will be CH2OH. Okay. So like that, how many molecules will be formed? 2 molecules will be formed. Okay, CH2OH. So these are the 2 molecules. Now, if I use concentrated sulfuric acid, every reagent purpose you should know. Whenever you wanted to remove water molecule, then the best reagent is concentrated sulfuric acid. Okay, sulfuric acid is very dehydrating agent. So as a dehydrating agent, it will remove the hydrogen from one molecule, OH will be from other molecule. Then the product will be something like this. I am writing it here, ClCH2, CH2. And here this oxygen is left over, so oxygen. Then this will be directly connected CH2, CH2 and Cl. The more you practice, the more reagents you will understand. So this is a practice based questions. Okay. So first question you may not be able to get idea, but once you start using it, then it will be very easy. You will get. Now what I told you, one vision should be on our products. Okay. See here, you can clearly see one, this chlorine is not required, this hydrogen is not required. Here hydrogen is not required, chlorine. So we should carry out the elimination. So for that we will do the alcoholic KOH. What we will do? Alcoholic KOH. Already I told you aqueous is different, alcoholic is different. In organic chemistry, you have to be very careful about what is written on the arrow. See, people will concentrate only KOH, but aqueous means substitution, alcoholic means elimination. Alcoholic means elimination. So this potassium will go and collect both chlorines. So for that we should take 2 moles. Okay. So minus 2 KCl. Okay. Is it understood? This OH will go and pick up hydrogen from here and pick up hydrogen from here. Then leftover will be C here. It is CH2 leftover and this hydrogen is picked up. So there will be CH. So there will be double bond. Oxygen, CH, double bond, CH2. So our ultimate goal was to get the divinyl ether. Di means 2, vinyl means CH double bond CH2, ether means oxygen. Okay. So this is the complete detailed explanation of second part. Will you feel that you will be able to understand this much easily when you go through the book? No, very good. Okay. So like that, now you will be able to solve the third question, I hope. Try, pause the video, then try, then check my explanation. Okay, now next third question. Dimethyl ether to diethyl ether. That means here dimethyl CH3 oxygen CH3. Then it must be converted to CH3 CH2 oxygen CH2 CH3. This is the third question. That means we have to increase the one carbon atom. Increase what? One carbon atom. Okay. So for that, the very best method is Wood's reaction. Okay. So first what we will do, we will carry out the reaction with HI. So HI will give you the C excess HI. excess HI will give you the H2O and iodine will be substituted. 2 moles of CH3 iodine and minus H2O will be there. Minus H2O will be there. Okay. So for Wood's reaction, what to be written on the arrow? Very good. 2 answers, 3 answers. Okay, so 3 answers received. Very good. Okay, so sodium and dry ether. What we have to use? Sodium in dry ether we have to write. Then it will be the wood product. Okay, one answer received but wrong. So CH3, it will be what? Double, it will be made as a double, and 2 sodium and iodine will be minus. So minus 2 NaI, minus 2 NaI, ethane will be produced. Okay. So now we got 2 alkyl groups. Okay. So, but only thing we have to introduce this oxygen. For that you can use the chlorine. You can use the chlorine where you will get as a CH3, CH2, Cl. So minus HCl will be there. Okay. Now this clearly I told you, commit to memory, because I know this type of questions are very frequently they are asking. Ag2O, dry Ag2O, that time these 2 moles will be automatically will get this product. Automatically will get this product. Okay. So the importance of the words I have used during the lectures you will come to know while solving the questions. Okay. So this is the third question. Now let us see the fourth question. Fourth question is ethyl iodide. C2H5 iodine should be converted to C2H5. Very simple question. You will feel simple now because you have practiced a lot. Okay. So first of all, what you will do? Aqueous KOH. Aqueous KOH will do which reaction? Substitution or elimination? So once you use the aqueous KOH, substitution will take place. C2H5OH will be coming. Now see here, this reagent already we have used. From here to here, already recently in the one of the question, we have used one alcohol is to be converted to ether. Preparation method also we have used. Just now also I have told the speciality of that reagent. That reagent is very thirsty. It will bring the water from that. What is that reagent? Okay, so for removal of water molecule, always we can use the concentrated sulfuric acid. It is one of the good dehydrating agent. Which agent? Good dehydrating agent. So as soon as when you use concentrated sulfuric acid, it will give you the ether. Okay. So these are the 4 questions using the different procedure, different product. If you understand this similar questions, you will be able to solve them. Okay. Now let us see the next questions. Okay, here it is a comprehension question. If you are able to solve one comprehension question, means it is equal to 3 to 4 questions. Main problem students are facing as per me when I discussed with the students and got a solution to that problem. Okay. When you bring out some problem to which chem, when you bring out some problem to our which chem, you will definitely get some solution. Okay. So here, according to this, what you have to write, the main problem is that so much English is stuffed over here. So remove all that English. You write only reactions. You write A. Okay. A is a ether. A is a ether. And have formula of C6H14 oxygen. Okay. Now one fine day it is treated with HI. That to how much? It is very excess. It is heated in very excess. Okay. Then it give 2 product B and C. So which are alkyl iodide? This is also alkyl iodide. Okay, alkyl iodide, and this is also alkyl iodide. Okay, on oxidation of B, on oxidation of B gives a D. D is a acid, carboxylic acid. Okay, on oxidation of C gives a E, which is a mixed ketone. Mixed ketone, already I told you in my first lecture of the aldehyde and ketone. Okay, so mixed ketone, classification of carbonyl compound. So every lecture, every word, every sentence is very important. It is going to affect you a lot. Okay. So this is the question given. Now we will have clear understanding. See here, E should be a ketone. When you will get ketone? When it is 2 degree. When it is 2 degree. Okay, when this is 2 degree, that means alkyl iodide is at 2 degree. It is giving acid, that means it is 1 degree. Understood? So total how many carbons we have? We have C6H14. Okay, total we have how many? C6H14. So for that what we will do? We will combine this in such a format that you should get in the form of the ketone. So for this what I will do? This total oxygen I will explain in the next page. Okay, so here I will write the reaction so that it should be able to satisfy all conditions. So here this is the secondary. It should be what? Secondary. Okay. So for secondary, I have to write it like this only. There is no other go. So CH, it will be CH3, then it will be CH2 and CH3. Okay. So this is what given actually. Now, whether I will check whether it is suitable or not. If it is A, so when it is heated with 2 moles of HI, 2 moles of HI. So one iodine will go here and another iodine will go here. Okay. So it is going to form CH3, CH2 iodine, and it is going to form CH iodine, CH2, CH3, and here also CH3. Okay. Now for oxidation, when you oxidize any 1 degree haloalkane. Okay, first on hydrolysis it will be alcohol. So CH3, CH2OH. Okay. Now on oxidation carboxylic acid. So CH3COOH. Is that clear? So this is A. Now the which is giving carboxylic acid, which is giving carboxylic acid. So B is giving carboxylic acid, C is giving the ether. Okay. Okay, on oxidation of primary alcohol. This is a primary alcohol. So we will get carboxylic acid. Now on hydrolysis, this iodine will be substituted with OH. Then it will be CH, CH3, CH2 and CH3. Okay. Now on oxidation, as it is a secondary alcohol, this will be converted to ketone. So once again I will explain, don't worry. I will compare the previous. See here, this is the answer now. Okay. So this is E, which is a mixed ketone. Mixed means here it is methyl and here it is ethyl. There is a word used mixed. That's why I have to take this side 4 carbon atoms, this side 2 carbon atoms. Okay. And it is ketone, therefore you have to take secondary. How I will get idea to write like this, is it clear now? So I will show question once again. See, this was the question. An ether having molecular formula C6H14 oxygen. So here on main condition is B is giving acid, okay, which is called as a D. That means here our D is a acetic acid. D is what? Acetic acid. And C gives a mixed ketone E. So this is the mixed ketone E. And what is C here? This one. What is B here? This one. So to make it ketone, I have to take secondary iodine. And to make it mixed, one side should be, I can take both side propyl, but why I am not taking? Why? Because one side I want ethyl, another side I want butyl. Then only it will give you the mixed ketone. Okay. So accordingly, I have arranged and got the A formula. One side butyl, another side ethyl, and secondary ketone. Okay. Primary carboxylic acid. Is that clear now?